So, good day, class. So, let us have now our lecture for today. So, it's all about the details on the weathering process. So, this is actually the continuation of your geomorphic process, wherein we have initially discussed on geological agents and some alterations on minerals and earth materials by these geologic agents. So today, we further expand our knowledge on that matter so that we could fully understand what other factors may cause alterations on geologic materials. So, as an introduction, our Earth is made up of rocks. And of course, rocks are composed of minerals. And our Earth itself is changing. So why is it so? We'll find out all throughout the slides today. So as an example, rocks are getting changed. So for your information, a sea sand were once a quartz. These quartz are broken apart, traveled along rivers, channels, and streams, and ended up with a small sugar-sized grains. Yun yung mga buhangin sa sea or the landscape of the beach. Okay? So that is because there is the process called weathering. So the process of disintegration and decomposition of rock in general called weathering. So last time we have learned about geological agents and some sorts of process of these geological agents like abrasion, okay, and the formation of different landscapes such as dunes, okay. So what are the controlling factors of weathering? So number one, we have the composition and the structure of rock, and then the nature of the ground slope, and then the climatic variations and the floral effects. So as a review, we have the following agents of weathering. Of course, number one is the wind, and then the frozen water or the glaciers, and then the running water. Next, we have the sea waves and the underground water. Now, weathering could be in three types. It could be physical in nature, it could be chemical in nature, or biological in nature. So first we have physical weathering. So physical weathering is also known as mechanical weathering. So it is caused by the change in temperature due to expansion and contraction of rocks breakup. So aside from the temperature change, of course, when we have a temperature change, there will be a residual effect on the earth material. So the earth material could expand or contract. So kapag uminit, magko-contract or hahaba, or it will expand. Or sorry, kapag uminit, when temperature increases, your material will expand, okay? And when there is a decrease in temperature, of course, there is a cool down, and cooling down implies contraction. Okay, so your material could be expanding or contracting. So because of that, the rocks will tend to break. Okay, so that is the concept of physical weathering. So aside from that, physical weathering is the breaking down or fragmentation of rocks due to environmental factors, in which I will discuss it in a short while. So physical weathering happens due to the process of isa lang yung changing of temperature, and another one is the freezing action of water and the roots growing plants, which disintegrates rock. So let us have some examples of physical weathering. So let us highlight here that physical weathering is that there's no change in rock's chemical composition. So there will be no chemical alteration on the substance, okay, of the material. So number one, the agents of mechanical weathering includes temperature. So it causes repeated expansion and contraction. As I have said, if we increase the temperature, the material will expand, and if we decrease it, the material will contract. That is why in road construction, you will notice that there should be a break between the material, or there should be thermal joints between those constructed roads. Okay, so meaning ini-slice nila yung roads because of the expansion and contraction, or in short, the effect of the thermal expansion. So one of the examples is ice wedging. So it is actually the frost action, the freeze-thaw cycle, when liquid water goes into cracks and then freezes, causing the cracks to get wider. So if the water will be frozen into ice, of course, there will be an expansion. Okay, so there will be an expansion of the ice that are being inserted or frozen on the joints, and because of that, your cracks will be magnified, okay, and until it will break. Okay, so the cracks get wider until it will be separated. So this is also called as frost wedging. So first it will fill the crack, and as the water will freezes to ice, it will expand and widens the crack until it breaks. So another physical weathering is the organic activity. So it could be a root pry, burrowing animals, or human activities. So on the photo you can see here that there is a root wedging. So when we say root wedging, the roots of plants or trees will tend to expand, and of course it will break some material like rocks. So you can see it on the picture. So one of the geological agent also is the gravity, and gravity will tend to also cause physical weathering. So you can see here that from weathering, by law of by gravity, it will have a mass wasting and erosion. So that will also tend to have abrasion. Okay, abrasion on the surface. When we say abrasion, it is mechanical scraping, wherein it will break the rock apart. Okay, so you can see on the photo we have a lot of different cases of the effect of the gravity. We have the slump, rockfall, debris slide, and mud flow. So all in all, it is within the context of landslide. So here we can see a rockfall because of the gravity. And the governing factor on landslide is, of course, the angle of the slope. Why? Because the more steeper, the more the effect of gravity, and the more susceptible to rockfall or landslide. So here we have the abrasion. So it is the wearing away by solid particles. So it is a mechanical scraping. Kaya nga it will be converted, or the solid material somehow will be converted into particles, and eventually it will turn to more finer grains later on. So another physical weathering is the unloading. So this is actually the expanding of high pressure rock when exposed to lower pressure. So here you can see in the picture an onion skin, para siyang balat sibuyas, that tends to have a sheet. It's like a sheet that is being scraped layer by layer, and this is what we call sheeting or exfoliation. So you can see the flakiness on it because it is like onion skin. Okay, so the classic sheeted granite or granite along the Chago Road in Yosemite National Park. The granite is broken into gently dipping plates by unloading joints. By the way, bakit ba naging unloading yung tawag dyan? So, here's the explanation. So, it came from a concept of a buried material. Of course, this is covered with soil material originally. So it was once buried by soil, and of course the soil by gravity will tend to have a pressure on this inner material, and this inner material is of course harder. Okay, it is a harder material, and by weathering process and geological agents, of course, the particles here will have will undergo degradation, aggradation, and denudation. Okay, So mawawala yan, and eventually this harder material will remain at the surface. And because of that, originally, may resisting force na dyan sa loob to counter the weight here. And as the weight will be removed, the inner pressure will burst onto the outer surface. And that will cause flaking, sheeting, or exfoliation. Okay? Kaya unloading. Na-unload yung load. That is why the inner pressure initially will be released. Okay? And once that will be released, there will be a change in volume. Okay? Perhaps an increase in volume. So that will tend to have an exfoliation. So here we can see here another case. So this is a mountain that was unloaded. Inside is a harder material, and as the load was removed, the outer pressure was released, causing it to have a flaking. So another physical weathering is the contraction due to crystallization. So the surface pattern on this pedestal rock is honeycomb weathering caused by crystallization. So this is found in Yelyu, Taiwan. So kung makikita nyo, I think this shall fall under chemical because there's the presence of the salt, wherein salt will tend to alter the composition of your material. So salt weathering of building stone on the island of Gazo, Malta. So itong bricks na to, para siyang nag-honeycomb because of the salt or contraction due to crystallization. So in summary, we have physical weathering or mechanical weathering includes unloading, frost action, root wedging, as well as temperature change. So moving on to chemical weathering, of course, the key term here is alteration. Alteration meaning there is a change on the ionic structure of the material, the alteration of the mineral components, the removal of substances, or maybe a new formation of substances because of chemical weathering. So there are a lot of factors here now. Okay. So the agent of chemical weathering is, of course, water. Why water? Because it dissolves minerals in rock, making them weaker. So in a while, I'm going to discuss some of these processes. So aside from water, we also have acids. So acids dissolves minerals in rocks. Some of the examples, we have carbonic acid, acid rain, or plant acid. So the first formation of acid, remember that water plus carbon dioxide is equal to carbonic acid. I repeat, the combination of water and carbon dioxide will be equal to carbonic acid, and it will have the process of carbonation. wherein water absorbs carbon dioxide when rain falls, or from decaying material. So kapag umulan, pwedeng ma-absorb ng water yung carbon dioxide coming from the atmosphere. Okay? Or the rainwater will pass through a decaying organic material. So remember, kapag may decaying, there will have a carbonic ions that will form carbon dioxide, and the carbon dioxide will tend to be dissolved in water, eventually to form carbonic acid. So usually, when this happens, this carbonic acid will tend to penetrate into ground material, or in short, it will percolate on your material and then bababa yan. Kaya kung makikita natin, this process is common to some underground caves. Okay? Through some material like what we call limestones, and it will form several rock formation underneath. You can see that in the cave. Okay, so that is the first formation of acid, yung carbon na tutunaw sa tubig. And then the second one is the precipitation. So water in the atmosphere absorbs yung pollution, yung emission from different factors. Okay? So yung mga sulfur oxides and nitrogen oxides, through a series of chemical reactions, these pollutants are converted into acids. And then magpo-form siya ng ulan. Okay? And that precipitation is what we call the acid precipitation or the acid rain. So here's the diagram. Of course, from the emission of those pollutants like factories, transportation, industries, electricity generation, it will move up to the atmosphere, and there will be a chemical transformation. Okay, magko-combine yung mga elements, and then it would be released through dry deposition and particulates, and some of these gases will be transmitted to the wet deposition, and that will form an acid rain and snow, or maybe a snow. Okay, so the third acid is the plant acid. So here, when plants decay, they release acids that react with the minerals in rock. Okay, so that is why it is called plant acid. So we now move on to the chemical weathering processes. As we can see in the figure, it will certainly alter the shape and the composition of the rock structure. So we have 3,000-year-old, medyo fine pa yung pagkagawa 3,000 years ago. And after 100 years in New York, of course, laki na ng pinagbago. Okay? Parang masyado nang halata yung pagka-taper nitong Egyptian obelisk after 100 years. So, these are the chemical weathering process we are talking about. First, we have the hydration. then the reduction, and then the oxidation, carbonation, dissolution, leaching, and the process of hydrolysis. Okay, so first we have dehydration. So by dehydration, by the term itself, hydrate, it refers to the absorption of hydrogen ions. So it is actually one of the most common processes in nature and works with secondary minerals such as aluminum oxide and iron oxide minerals and gypsum. Soil-forming minerals in rock do not contain any water, and they undergo hydration when exposed to humid conditions. So when your atmosphere is having a high content of moisture, okay, humid conditions, or water vapor on air, that will cause hydration process. So we can see here on the slide, focus yourselves on the chemical equation here. Yung ferrous oxide. By the way, ferrous is iron, ano? So, pag sinabi nating iron oxide, that refers to rust. Okay? Kalawang. And you know that rocks tends to weaken the material. So, it is also true to rocks when it is true to metals. Kasi yung metals, galing din yan sa ano? Sa rock minerals. So, we can see here on the chemical equation, the Regis hematite combined to 3 counts of hydrogen, oxygen, and another hydrogen. So this equation here will have 3 water, di ba? H2O. Yeah. And once this water will be combined to the ferrous oxide, okay, ferrous oxide, it will become limonite or yellowish in color. So we have here hematite, it is a reddish color, will turn into limonite. And another example is aluminum oxide combined with 3HOH. Of course, aluminum oxide just the same, but it will become hydrated. So that is from bauxite to hydrated aluminum oxide. Here it is. So after hydration process, hematite will turn into limonite. Okay. So hematite is one of the most abundant material, ano? It can be found on shallow crust, so sa mga mabababaw, and the Earth's surface. So it is actually the most important ore of iron, ano? Yung hardness niya is ranging from most hardness of 5.5 to 6.5. So mas abundant yung iron content niya, almost 70%, ano? That is why this stone ginagamit sa feng shui and healing. And naging tinawag pa nga itong healing stone because accordingly it boosts self-confidence, self-esteem, and willpower. So meaning, nagdadala ito ng positive energy. And it is considered as semi-precious stone, itong hematite. Okay. And if hematite will be hydrated, magiging limonite yan, and it will tremendously reduce its hardness, dropping it in a range from 1.5 to 5.5. Okay? So 1.5 to 5.5. So before, 5.5 to 6.5 itong hematite. Okay? So kitang-kita naman napaka-intact nito compared to the limonite. Okay. Here we have the bauxite after the hydration process. It will turn into hydrated material. Okay? So, hydrated material, itong bauxite kasi malambot na yan, ano? So, yung most hardness niya is 1 to 3. So, the color variation is from white to gray to reddish brown with a pisolithic structure. So, pisolithic daw, maraming piso. Pisolithic structure. So, it is actually the principal ore of aluminum. Yun yung bauxite. So, aluminum oxide compounds, the most abundant element of the bauxite, also contains silica, iron oxide. Yung iron oxide, remember, that is a rust, ano? And titanium oxide. Okay? So, this is a rock formed from reddish clay material. Okay? So, kapag nag-hydrate pa yan, of course, ganito na mangyayari dyan. It will have a disintegration on the particles. So, here we can have the picture, the disintegration of the material after the rocks absorbing water and then expand, creating stresses which causes the rock disintegration. So this is the hydration process. So this is the hydration weathering. Some of the weak material was already removed, okay, causing it to have several land formation or geomorphic formation. Okay, before we proceed to the other type of chemical weathering, let us differentiate here ferrous versus ferric. So ferrous is actually combined with oxide, ano? Ferrous oxide or ferric oxide. When we say ferrous, ito yung tinatawag na +2 oxidation state of iron. While ferric, mas mataas, +3 oxidation state of iron. Because of that, mas weak yung ferrous than that of ferric. So ferric is relatively more stable than ferrous. So ferrous here can be formed through reduction of ferric ions. Kasi nga, kapag na-reduce yung ferric ions, magiging ferrous na siya. Okay? While that ferric, it can be formed through oxidation of ferrous ion. When we say oxidation, nadadagdagan yung oxygen ions. Kaya pag dinagdagan mo yung ferrous, magiging ferric. Okay? So that's it. So moving on to the process of oxidation, it is actually the addition and combination of oxygen to minerals. So the absorption is usually from O2 dissolved in soil water and that present in the atmosphere. The oxidation is more active in the presence of moisture and results in hydrated oxides. Anyway, pag sinabi nating ferrous oxide, iron oxide din yun. Kalawang pa rin yan. Okay? It is rust. Kung makikita natin yung ferrous, nagiging ferric because nag-combine yung isang oxygen. Meaning, this is an increased oxygen ions. Okay? Yung ferrous naging ferric. And then, we have here magnetite plus oxygen. So, alam nyo ba yung magnetite? From the term itself, it is attracted to a magnet and become a magnet itself. So, the hardness of this from most magnitude is a 5.5 to 6.5 scale. Okay. And after oxidation, it will weaken to hematite. Anyway, yung hematite a while ago, parehas lang naman sila ng hardness na 5.5 to 6.5. Only that, nawala yung pagka-magnet ng mineral. Okay? Parehas lang sila. Matigas yung dalawang yan, hematite tsaka magnetite. Ito yung sinasabi ko kanina na it is a healing stone and it is a semi-precious mineral. Okay? If yung material mo is hematite naman, dinagdagan mo ng 3 water, it will turn into limonite. Okay? So, parehas sa kanina sa process of hydration. Okay? So, this time, nagkaroon kasi dito ng hydrogen. Okay? So, this is it. From magnetite to hematite. So, oxidation is the process by which the oxygen combined with water and minerals in the rock, such as calcium and magnesium. When iron reacts with oxygen, reddish-brown iron oxide is formed. Then the iron oxide crust crumbles easily and weakens the rock. As we have said, iron oxide is a rust. And rust, kinakain niya yung minerals. Just like in metals. And metals came from rock mineral. Remember that. Okay. So, yung opposite ng oxidation is actually reduction. So, kung combination yung oxidation, this time, the process is the removal of oxygen ions. Okay? So, it will change the soil color to gray, blue, or green as ferric iron is converted to ferrous iron compounds. Yung ferric, plus 3 yan, bawasan mo magiging ferrous. Magiging plus 2 iron oxide. Okay? And then under the conditions of excess water or water-logged condition, where there is less or no oxygen, reduction takes place. Kung nababad yan, nababad yan sa tubig. Pagbabad yan sa tubig, of course, oxygen, especially yung oxygen is stagnant, Okay, waterlog. Hindi running water. Kasi yung running water, it will generate oxygen. Pero kapag yan, stagnant water, magfo-form yan ng reduction. So as we can see, hematite less 2 ionic oxide, it will have ferrous oxide. Kalawang na, purong kalawang na yan. Okay, that is how reduction weakens the material. Okay. So this is oxidation, weathering. Okay. So next, we have the carbonation. So again, water plus carbon dioxide is equal to carbonic acid. Acid rain absorbs carbonic acid, and then through percolation, bababa yan sa mga caves. We'll have some dissolving of materials underneath. Okay. Carbon dioxide, when dissolved in water, forms carbonic acid. And you can see here in the equation the combination of the ions. So this carbonic acid attacks many rocks and minerals and brings them into solution. When we say solution, magiging ano yan, parang asin, natutunaw na yung mineral. So the carbonated water has an etching effect up on some rocks, especially limestone. So the removal of cement that holds sand particles together leads to their disintegration. Okay, I think that is very clear. So from calcite, because of carbonic acid, it will become calcium bicarbonate. Carbonation is the process by which carbon dioxide in water or moisture surrounding air forms carbonic acid and reacts with the minerals in the rock. So this process weakens the rock, thus breaking it down in the process. Carbonation weathering gives altered earth material a characteristics yellowish brown to red color. So here we have the sample picture of carbonation weathering. Kung nakikita nyo, may mga splat siya ng kalawang. So another chemical process or chemical weathering is dissolution. So rocks, when in water, react with acids in the water and dissolve. So we can have a clue that dissolution happens to a rock is the presence of small holes, parang binutas ng mga langgam. Okay, so there are some portion of this rock that are soluble. Again, the agent here is the water. Okay, we also have chemical weathering, leaching. So water dissolves chemicals in rocks and washes them away. So this is iron leaching. So ito portion lang kasi hindi naman puro na soluble yung material. But this time, water dissolves chemicals in rocks and washes them away. So this is the leaching process. So here we also have the hydrolysis. It's the most important process in chemical weathering. So ito, hydrogen ions reacts and forms a new substance. So a classic example is that yung feldspar will turn into clay material. Okay. So kung makikita natin yung ortho klase in the equation, so halos pares lang naman yan, kaya lang hiniwalay niya yung potassium material dito, nag-combine sa other minerals, kaya new formation na siya, acid silt clay na. Okay, and then from these two equations, nahiwalay naman yung isang H dito. Okay, so kung baga nagra-rumble na, naghalo-halo na, because of the recombination, it will have a new substance, a new formation of the substance. So some substances present in the rocks are directly soluble in water. The soluble substances are removed by continuous action of water, and the rock no longer remains solid and form holes, rills, or rough surface, and ultimately falls into pieces or decomposes. The action is considerably increased when the water is acidified by the dissolution of the organic and inorganic acids. Okay? So in this case, nawala na yung hydrogen, or this is water actually. Nag-dry up na yung tubig, that is why naging asin na siya, or NaCl, sodium chloride. So here, yung sinasabi ko kanina, feldspar has just turned into granite, into clay mineral. So clay mineral, madali yang makrumble, and thus it weakens the rock, causing it to break down. So yan, hydrolysis weathering. Okay. So moving on, I think we are done with the chemical weathering. So let me have a note here that the pyrite element harms rock. So why do we have to jump on this? Because yung pyrite kasi ginagamit din yan in some construction. But I would like to highlight here that it is actually not desirable in construction, especially in road construction. So by and by I will explain that one. So pyrite is the most dangerous minerals on earth. It is a common accessory minerals in rocks. It makes more vulnerability of rock weathering since it releases sulfuric acid through the process of oxidation. Yung pyrite kasi kapag na-oxidate, oxidate yan, okay, it will have a product of ferrous sulfate as well as the sulfuric acid. So yung acid gases in the atmosphere, that is so dangerous, no? Meron tayong tinatawag na arsenic. Kapag nag-oxidate yung pyrite, magre-release ng arsenic. Itong arsenic na to is cause of lung diseases. Kaya yung mga minero, vulnerable sila sa mga ganitong sakit. Because arsenic is very harmful in health, in human health. Kaya nga tinatawag na the most dangerous minerals on earth. Okay. So, remember that the process of oxidation is a natural process, ano? And yet, nakakatakot yung effect ng pyrite. So, pyrite in construction subject to certain conditions. Pyrite is problematic in confined construction, such as underfloor filling and bridge embankments. So, hindi siya desirable na maging tambak. This is due to a chemical reaction that can cause pyritic backfill to swell. So, namamaga yan. Okay? So, there is the element of swelling of this material. So, construction material containing relatively large amounts of pyrite materials are likely to expand, crack, or crumble over time. So, this occurs when from vital crystalline pyrite, air and moisture mix, causing a chemical reaction to occur that creates expanding crystals within the material. Okay, so I think we're done here. So we have several slides that includes chemical weathering. So ito nga yung carbonation. Acid rain creates caves. Of course, the acid rain also dissolves minerals on statues. The effects of acid rain has also alteration on stone buildings. So acid rain is weathering. This is stone with hieroglyphics on it. It is on a loan in an Egyptian museum. Ito. Using chemical analysis, scientists determined that the original statues of rock were built before 1200 BC before Christ. Okay. So, yung chemical analysis pala, it will also track history. So, we can see here, this is one of the 3 Great Pyramids. And obviously, it has undergone chemical weathering. Kasi hindi na nga ganun kaganda yung surface niya. And it is obvious that there are chemical alterations that this pyramid have undergone. And I think that ends our session for the details on physical and chemical weathering. So, for your advanced reading, I think you should have to research on biologic weathering process. So that was mentioned as one type of weathering process. So what is biologic weathering process all about? So actually it is one type of weathering. Ayan. Physical, chemical, and biological weathering. So in this case, thank you for attending this lecture and see you next meeting. Good day.